Hello friends, today I am going to discuss one important topic, that is coaxial system of spheres. Okay, so coming to the definition of coaxial system of spheres, a system of spheres is said to be a coaxial system of spheres if any two spheres of the system have the same radical plane, have the same radical plane. So whenever if any two spheres of the system have the same radical plane, so then we say that system of spheres is a coaxial system of spheres. Okay. Here, how can we find the radical plane means? Suppose if we are having two spheres S1 and S2, if we subtract those two spheres, then we get a radical plane. Okay. In that way, we can find the radical plane. Right. So coming to the note point 1. If S is equal to 0, comma, S dash is equal to 0, are two spheres in a coaxial system, then S minus S dash is equal to 0 is the radical plane of the coaxial system. Coaxial system of spheres. Okay, a system of spheres is said to be a coaxial system of spheres. So if any two spheres are having the same radical plane, so that is the definition of coaxial system of spheres. So whereas coming to the radical plane, how can we find a radical plane for the given spheres? Means just we have to subtract the spheres, whatever the spheres we are having in a coaxial system, we have to subtract those two spheres, then we get a radical plane. Okay, so in this way we can get a radical plane, right? Coming to the next point, that is, if S is equal to 0, a sphere, and V is equal to 0 is a plane, then the equation S plus lambda U is equal to 0, where lambda is parameter represents a coaxial system of spheres with radical plane U is equal to 0. So whenever we are having a sphere equation together with a plane equation, we can represent a coaxial system of spheres with those two equations. So that is S plus lambda U is equal to 0 represents a coaxial system of spheres. S is equal to 0 and the plane U is equal to 0. Okay, right. So coming to the next point, this is very, very important point, that is limiting points. Limiting points. The point spheres in a coaxial system of spheres are called limiting points of the coaxial system. So the point space in a coaxial system of the spheres are called the limiting points. So the point sphere is nothing but radius having 0. So whenever the radius is 0, we say that the particular sphere is a point sphere. Okay? The point spheres in a coaxial system of spheres are called the limiting points of the coaxial system. That is the definition of limiting points. Note, the limiting points of a coaxial system are denoted by the centers of the corresponding point spheres. The limiting points of a coaxial system are denoted by the centers of the corresponding point spheres. So the center of the corresponding point spheres are called the limiting points. Okay. Here what we have to do is we have to find the limiting points for the coaxial system of spheres. So for limiting points, the radius should be 0, and the centers of the coaxial system of the spheres are the limiting points of the corresponding coaxial system. Okay. So how can we find the limiting points? So just we do one problem. Right. Coming to the problem, find the limiting points of the coaxial system. Coaxial system of the spheres x square plus y square plus z square minus 20x plus 30y minus 40z plus 29 plus lambda into 2x minus 3y plus 4z is equal to 0. So here we have given a coaxial system of spheres. So coaxial system of spheres is nothing but a sphere equation together with a plane equation. We call this as a coaxial system. So right now we have to find the limiting points for this coaxial system of spheres, and this is very, very important model. Okay. So coming to the solution. So first we have to write the given coaxial system. Given coaxial system of spheres is, so just write what we have given, that is x square plus y square plus z square minus 20x plus 30y minus 40z plus 29 plus lambda into 2x minus 3y plus 4z is equal to 0. Okay. So this is the given coaxial system, and we have to rewrite this equation as x square plus y square plus z square, and if we take x common, we get minus 20 plus 2 lambda. Similarly, if we take y common, we get 30 minus 3 lambda. Similarly, if we take z common, minus 40 plus 4 lambda plus 29 is equal to 0. So this is equation number 1. So we have to treat this particular equation as equation number 1. Now we have to find the center. Now, now the center of equation 1 is, here the center is nothing but we have to write the half of the coefficient of x by changing the sign of x. Okay, and half of the coefficient of y by changing the sign of y, and half of the coefficient of z by changing the sign of z. So those are the those terms represent the center. So I'm writing the center, that is so 2 lambda minus 20 by 2. This is the half of the coefficient, and I am changing the sign, which is minus. Similarly, minus of 30 minus 3 lambda by 2, half of the coefficient of y with changing the sign. Similarly, 4 lambda minus 40 by 2, and we have to change the sign, this is minus. So this is the center of the equation 1. Okay, so if you write it neatly, we get c is equal to 2 lambda minus 20 by 2 can be replaced. If you multiply with minus, we get 10 minus lambda. Okay, and coming to the next one, so here we get 3 lambda minus 30 by 2. Here we cannot cancel any term, so that we have to write it completely. And from here, also we get the 2 cancel from numerator and denominator, so that we get 20 minus 2 lambda. So this is the center of equation 1. So treat this as equation 2. So for limiting points, the radius is equal to 0. We already discussed that. So for limiting points, the limiting points of the coaxial system of spheres are called the point spheres are called the limiting points. So for point spheres, radius should be 0. So in order to find the limiting points, we have to consider that the given sphere is a point sphere, so that the radius should be 0. So that I am writing for limiting points, radius is equal to 0. Okay. So here radius is nothing but we having the formula for radius, that is square root of u square, means 10 minus lambda whole square, plus v square, that is 3 lambda minus 30 by 2 whole square, plus w square, 20 minus 2 lambda whole square, minus d, that is minus 29. So minus d is, that is minus 29, is equal to 0. Okay. Next, if you squaring on both sides, then we get 10 minus lambda whole square plus 3 lambda minus 30 by 2 whole square plus 20 minus 2 lambda whole square minus 29 is equal to 0. On expanding the terms, we get 100 plus lambda square minus 20 lambda plus 9 lambda square plus 900 minus 180 lambda by, here we are having 4 plus 20 is 400 plus 4 lambda square minus 160 lambda minus 29 is equal to 0. Since we are having the LCM 4, so that by taking the LCM 4, we get 400 plus 4 lambda square minus 80 lambda plus 9 lambda square plus 900 minus 180 lambda plus 1600 plus 16 lambda square minus 640 lambda minus 116 is equal to 0. Okay, right. Here, while expanding 20 minus 2 lambda whole square, we get 400 plus 4 lambda square minus 80 lambda. Okay, minus 29 is equal to 0. So by taking the LCM 4, so we get 400 plus 4 lambda square minus 80 lambda plus 9 lambda square plus 900 minus 180 lambda plus 1600 plus 16 lambda square minus 320 lambda minus 116 is equal to 0. So by simplification, by simply simplifying all these terms, we get 29 lambda square. Since we are having 16 plus 9 plus 4, that is 29 lambda square. Next minus 580 lambda plus 2784 is equal to 0. So this is a quadratic equation in lambda. So I have cancelled 29 tables from this equation so that we get lambda square minus 20 lambda plus 96 is equal to 0. So here we are having the factor set 12 8s are 96. So by writing the minus 20 as minus 8 lambda minus 12 lambda, so we get lambda into lambda minus 8 minus 12 into lambda minus 8 is equal to 0. So that we get finally lambda is equal to 8 comma 12. So whenever we get the lambda values, then we can write the limiting points of 1. Okay, so that we can write, therefore, the limiting points is, so first put lambda is equal to 8 in 1, in the, sorry, in equation 2, that is center. That is substitute into, we get, so 10 minus 8 comma 3 into 8 minus 30 by 2 comma 20 minus 2 into 8. So it means we get 2 comma 24 minus 30 is minus 6 by 2 means minus 3 comma, so 20 minus 16 is 4. So 2 comma minus 3 comma 4 is one limiting points. And if we put lambda is equal to 12 in equation 2, once again we get 10 minus 12 comma 3 into 12 minus 30 by 2 comma 20 minus 2 into 12. So then we get, so 10 minus 12 is minus 2 comma 12 is 36 minus 30 means 6 by 2 means 3 comma 20 minus 24 is minus 4. So minus 2 comma 3 comma 4. So therefore the limiting points of the coaxial system of spheres are 2 comma minus 3 comma 4 and minus 2 comma 3 comma minus 4. So in this way we can find the limiting points of the coaxial system. So once again coming to the problem, here we have given a coaxial system of sphere. Coaxial system is nothing but a sphere equation together with a plane equation. So I have written the given coaxial system. After writing the coaxial system, next we have to modify the given equations like x square plus y square plus z square plus, since we are having two x terms, so that we have to write x terms in one place, similarly y terms at one place and z terms at one place, and finally constant. So after writing this equation, in order to find the limiting points, first we have to find the center of the equation. Center. Here center is nothing but we have to write the half of the coefficient of x by changing the sign. Similarly, half of the coefficient of y by changing the sign and half of the coefficient of z by changing the sign. Okay. On simplification, we get the center of the sphere is this equation number 2. Okay. So after finding the center, In order to find the limiting points, we have to write the radius is equal to 0. Why? Because I am writing the radius is equal to 0 means the limiting points of the coaxial system are denoted by the centers of the corresponding point spheres. So you are saying that the point spheres, the centers of the point spheres are the limiting points. Here point sphere, whenever we are saying that the sphere is a point sphere, for point spheres the radius should be 0. So that I am writing radius is equal to 0. And we are having the formula for finding the radius, that is u square plus v square plus w square minus c is equal to 0. So I'm squaring on both sides, we get 10 minus lambda whole square plus 3 lambda minus 30 by 2 whole square plus 20 minus 2 lambda whole square minus 29 is equal to 0. And on simplification, we get a quadratic equation. And on solving the quadratic equation, we get two values for lambda. And if we substitute those two values in the center, that is in equation 2, so then we get a two centers. Okay, whenever we are having two values for lambda, so definitely we will get the 2 points, and we call those 2 points as the limiting points of the coaxial system of spheres. So in this way, we can find the limiting points of the coaxial system of spheres, and this is very, very, very important point, important model for examination point of view. Okay, right. So, and I am giving you one more problem. So to solve this problem, so you have to try. Here I have given you one problem, that is find the limiting points of the coaxial system of spheres. Here I am giving you, I have given you two spheres. First of all, you have to find one plane equation. How can we find a plane equation is, so treat the first sphere as s is equal to 0 and the second sphere as s dash is equal to 0. So if you subtract s minus s dash, so then we get a plane equation. So by writing the coaxial system, we can use any one of the sphere equation together with the plane equation. So that s plus lambda u is equal to 0 represents a coaxial system of sphere equation. Okay, so first we have to find the sphere equation. After that, first we have to find the plane equation by subtracting these two. Okay, after that we have to write s plus lambda u is equal to 0, that represents a coaxial system of spheres. And then you can find the center. After that we have to put radius is equal to 0, and on simplification we get two values for lambda, and if we substitute those two values in the center, then we get two limiting points. Okay, thank you.